Welcome to my video. My name is John Ruiz Castillo and I will tackle about Avogadro's number. I will tackle you about Avogadro's number. The contents of our topic is introduction to Avogadro's number. Second is mathematical and scientific significance. Third is application of Avogadro's number. Fourth is the common misconception and clarification. Fifth is a solving problem using Avogadro's number. And sixth is summary and review. What is Avogadro's number? The definition of Avogadro's number, the symbol of Na is equal to 6.022 times 10 raised to the power of 23. Mole is negative raised to the power of 1. Defines how many entities are in 1 mole of substance. Constant for all elements and compounds. Definition and value. Avogadro's number is 6.022 times 10 raised to the power of 23, representing the quantity of particles in a mole. Crucial for linking atoms to measurable amounts in chemistry. Importance in chemistry. Avogadro's number is crucial in chemistry and as it links atoms to measurable quantities, allowing precise calculation and reaction and helping scientists understand the composition of substances. Historical background. Avogadro's number, introduced by Amedeo Avogadro in 1811, helped scientists understand the number of particles in a mole, crucial for studying chemistry and atomic level. Origin of the concept. Amedeo Avogadro's contribution. Avogadro's proposed that equal volumes of gases contain the same number of molecules, laying the foundation for Avogadro's number and advancing molecular chemistry understanding. So, here is the mathematical and scientific significance. Numerical and notation. Scientific notation of Avogadro's number. Avogadro's number is 6.022 times 10 raised to the power of 23 uses scientific notation to represent an extremely large quantity efficiently, essential for precise calculation in chemistry and physics. Comparison to other large constant. Avogadro's number, or 6.022 times 10 raised to the power of 23, is vastly larger than other constant like the speed of light or Planck's constant, highlighting its critical role in measuring microscopic particles. Avogadro's number in equation. A calculation of number of particles. Avogadro's number allows precise calculation of particles in a substance by multiple moles by 6.022 times 10 raised to the power of 23, connecting microscopic amounts to microscopic particles. Third is the application of Avogadro's number. So the balancing of chemical equation. Avogadro's number helps balance chemical equation by relating moles of reactants and products, ensuring the correct number of atoms are counted for in reaction. In physics, relating microscopic and microscopic properties, Avogadro's number link microscopic particles to microscopic quantities, enabling precise calculation of physical properties like mass, volume, and pressure in real-world physics application. Fourth is the common misconception and clarification. Difference between Avogadro's number and Avogadro's constant. Definition of Avogadro's constant is the Avogadro's constant is the exact number of particles, like 6.022 times 10 raised to the power of 23 in 1 mole, linking microscopic particles to measurable quantities in chemistry. Units and differences. Avogadro's number is a pure number, or the 6.022 times 10 raised to the power of 23, representing particles, while Avogadro's constant includes units like mole -1, linking amount of substance to moles for calculation. So, misinterpretation of mole concept. Mole as a counting unit. A mole is a counting unit like a dozen, representing 6.022 times 10 raised to the power of 23 particles, not a physical object or weight. Misunderstanding this leads to confusion in the chemistry calculation. Clarifying particle types counted. Avogadro's number counts particles, which can be atoms, molecules, or ions, not just atoms. Understanding the specific particle type is crucial to correctly apply to the mole concept in chemistry. So the example problem is how many water molecules are in 0.5 moles of H2O or the water. Solution. First is to identify the given number. Number of moles is equal to 0.5 mole. Avogadro's number is equal to 6.22 times 10 raised to the power of 23 molecules or mole. Step 2 is to apply the formula. Number of molecules equals to 0.5 mole times 6.22 times 10 raised to the power of 23 moles per mole, and please and cancel out the mole. And step 3 is calculate the result. Number of molecules is equal to 3.011 times 10 raised to the power of 23 molecules. So that's it.